These are the values of root 83 and root 253, which are accurate to the second decimal place. I calculated them only in a single step. There is a very simple way to approximate the square root of any number, even by hand. Here are the method and its principle. Root 83 is greater than root 81 but less than root 100. It's greater than 9 but less than 10. Since it's closer to root 81, it will be near 9. We need to determine what this value is. Let's call this value x. So root 83 is 9 plus x. We are going to express x as a fraction. We need to find its numerator and denominator. Calculate 83 minus 81, which is the square root of 9. The result is 2. This becomes the numerator of the fraction x. So, what's the denominator? There are two methods. The first method is to multiply 9 by 2. The result 18 becomes the denominator. Thus, the fraction is 2 over 18, approximately 0.111. So, the approximate value of root 83 is 9.111. The second method is to add 1 to the denominator 18 calculated in the first method. The result 19 becomes the denominator. The fraction is 2 over 19, approximately 0.105. In this case, the approximate value of root 83 is 9.105. Now, let's compare these with the actual value of root 83. The actual value is approximately 9.110. The error of the first method is smaller, but both methods provide approximations very close to the actual value. They are excellent approximations and they are very easy to calculate. However, there are cases where the second method is more accurate. Let's calculate the value of root 253. Since 15 squared is 225 and 16 squared is 256, it is between 15 and 16. Moreover, it's closer to 16. The approximate value of root 253 is 15 plus x. Express x as a fraction. Calculate 253 minus 225, which is the square of 15. The result, 28, becomes the numerator. The denominator is 15 times 2, 30. X equals 28 over 30, approximately 0.933. Thus, root 253 is approximately 15.933. Using the second method, add 1 to the denominator 30. The result is 31. In this case, x equals 28 over 31, approximately 0.903. Thus, root 253 is approximately 15.903. What is the actual value of root 253? It's approximately 15.905. The value of the second method is more accurate. Now, let's explore the principle behind this method. Since root 83 is greater than 9 and less than 10, its value is 9 plus x. X is greater than 0 and less than 1. To find x, square both sides and rearrange the equation. This results in a quadratic equation for x. Our goal is to find x. Since x is between 0 and 1, x squared is much smaller than x. If x equals 0.2, x squared equals 0.04. If x equals 0.1, x squared equals 0.01. As x approaches 0, x squared approaches 0 faster than x. In such cases, x squared can be ignored. Removing x squared from the equation gives us this. The numerator is 83 minus 81, 2, and the denominator is 19 times 2, 18. This matches the denominator from the first method. What happens when x approaches 1? If x equals 0.8, x squared equals 0.64. If x equals 0.9, x squared equals 0.81. As x approaches 1, x squared also approaches 1 slower than x. In this case, assume x squared equals x. This modifies the equation as follows. The numerator is 2 and the denominator is 19. This is 1 greater than the denominator from the first method. It matches the denominator from the second method. When root a lies between n and n plus 1, you can calculate its approximate value using one of the two methods. If root a is closer to n, like root 83, use the first method. If it's closer to n plus 1, like root 253, use the second method. By following these simple steps, square roots will feel much simpler.